March 23, 1945, 3:47 hours. The east bank of the Rhine River near Oppenheim. German Obergefreiter Klaus Richter adjusts his field glasses and watches American activity across 400 meters of dark water. Behind him, the twisted steel of Mainz Bridge lies scattered in the current, the last intact crossing destroyed 3 days ago. Wehrmacht engineers celebrated that night, toasting with schnapps in bunkers that now seem less secure. The Rhine was supposed to be impassable. What Richter can't see in the pre-dawn darkness will change everything in the next 18 hours. But first, you need to understand what the Germans thought they knew about rivers and warfare. Stay to discover the portable system that turned Germany's greatest natural barrier into just another engineering problem. The thermometer reads 34 degrees Av. Frost covers the observation bunker where Richter stamps his feet for warmth, his breath forming white clouds in the frigid air. He's been watching the Americans for 3 days now, ever since they established positions on the West Bank. Standard procedure: build up supplies, bring in heavy equipment, start the slow process of conventional bridging that takes weeks under fire. Richter has seen it before at other crossings. The Americans always brought too much equipment, too many supplies, wasteful but predictable. What he doesn't know is that across the river, inside wooden crates marked bridge components, lies technology that will make everything he learned about military engineering obsolete. Lieutenant Colonel James Morrison pulls his wool cap down against the Rhine wind and checks his watch for the third time in 2 minutes. 0352 hours. His hands shake, not from cold, but from the weight of what comes next. Morrison's 291st Engineer Combat Battalion had rehearsed this operation twice in England, but never under enemy observation. Never with 88mm batteries registered on every approach. Never with snipers watching from concealed positions just 400 meters away. The wooden crates around him contain steel sections that represent the most revolutionary advance in military bridging since the Roman legions learned to span rivers with timber and stone. But here's what makes this story incredible. Most of Morrison's own men don't know what they're about to accomplish. They've trained with these components, sure, but they've never seen the entire system deployed under combat conditions. They've never built a bridge while German artillery tries to kill them. They've never had to prove that American industrial genius can overcome 5,000 years of military doctrine that says rivers are permanent barriers. In 18 hours, they'll change warfare forever. But right now, in the pre-dawn darkness, they're just scared soldiers with unusual equipment. Morrison thinks about his wife Margaret back in Ohio, her last letter mentioning spring planting, and their daughter's upcoming birthday. He promised to be home for Easter. That promise depends on steel sections that weigh 570 pounds each and represent the marriage of British engineering genius with American mass production. Each panel measures exactly 10 feet by 5 feet. 6 sections per truck, 40 trucks in the convoy. Morrison does the math in his head. Enough steel to span the Rhine and change the course of the war, if they can survive long enough to assemble it. But what Morrison doesn't know, what nobody on either side of the Rhine realizes, is that they're about to demonstrate something that will reshape military thinking for decades to come. The Germans think they're watching conventional bridging. Morrison thinks he's following orders to span a river. Neither side understands that the next 18 hours will prove that geography itself can be defeated by systematic engineering and mass production applied to battlefield problems. German doctrine held that temporary bridges required extensive preparation based on engineering principles that hadn't changed since Napoleon's campaigns. Foundation work that took days, pile driving that required specialized equipment. Concrete pours that needed time to cure properly under optimal conditions. The Oberkommando der Wehrmacht estimated minimum construction time at 5 to 7 days for major river crossings, assuming perfect conditions and no enemy interference. Their manuals, written by officers who studied at the Wehrmacht Academy, addressed pontoon bridges, timber trestle spans, and captured enemy structures. Every German engineering officer knew the timelines. They knew the vulnerabilities. They knew that rivers were among nature's most reliable defensive barriers. What they didn't know What no intelligence file mentioned, what no prisoner of war had described, what no captured document revealed, was that across the Atlantic Ocean, American factories were producing bridge components like automobiles. Mass production techniques applied to military engineering, standard parts manufactured to precise tolerances. Modular construction that turned bridge building from specialized craft into systematic assembly. The revolution that was about to unfold along the Rhine had been manufactured in British factories and shipped to France in wooden crates that German intelligence dismissed as standard bridging equipment. Morrison signals his team leaders with hand gestures learned in night combat training. Sergeant Michael Torres grabs the first Bailey section from the truck bed, 570 pounds of precisely manufactured steel that represents months of British engineering genius and factory precision. Torres grew up in Detroit, working in auto plants before the war. He understands mass production, standardized parts, assembly line efficiency, but he's never applied those concepts to military engineering under enemy fire. 6 men lift in unison, 3 per side, a technique rehearsed until it became automatic. No cranes required, no specialized equipment, just muscle and engineering that turns bridges into manufactured products. The section moves toward the riverbank as German observers across the water note increased activity, but estimate days of construction time based on everything they learned about military engineering. What they're seeing contradicts their training, their experience, their doctrine. But human beings see what they expect to see, especially when the alternative is too revolutionary to comprehend. Richter focuses his binoculars on the American work site, adjusting the focus to penetrate pre-dawn gloom. Through the darkness, he can see figures moving around what appears to be construction material. Standard procedure, he tells himself. The Americans always brought excessive supplies. Wasteful, but predictable. He radios his company commander. Americans beginning bridging operations at Oppenheim. Standard timeline applies. Request artillery registration in 6 hours when construction becomes clearly visible. 6 hours would be exactly 5 hours and 51 minutes too late. But what was actually happening across the water was so far outside German experience that Richter's mind couldn't process it correctly. Instead of seeing revolutionary modular construction, he saw conventional bridging. Instead of recognizing mass-produced components, he saw standard military equipment. Instead of understanding that he was witnessing the future of military engineering, he saw what his training told him to see. Americans being wastefully American, bringing too much equipment to solve simple problems. The Bailey system represented a revolution in military thinking that extended far beyond simple engineering. Each 10-foot panel connected to the next through standardized pins and clamps. Mechanical connections requiring no special skills, no engineering expertise, no complex tools, no welding in the field, no custom fabrication, no measurements or adjustments. Factory precision meeting battlefield urgency through mass production principles that American industry understood better than any military in history. Donald Bailey had designed the system in 1940 after studying every military bridging failure of World War I, every bottleneck that turned river crossings into extended sieges. Bailey had never been in combat, never heard artillery rounds whistling overhead, never felt the pressure of enemy fire disrupting construction schedules. But his design would save thousands of lives and change military history because he understood something that traditional military engineers missed. Standardization enables speed, and speed saves lives. Rapid assembly through modular construction. Strength through repetition rather than massive single components. The principles that made American factories the most productive in the world applied to the deadliest problems soldiers faced in combat. At 0358 hours, the first section locks into position on the American riverbank with a distinctive metallic click that echoes across the water, steel pins sliding through hardened brackets with mechanical precision that represents months of quality control in British manufacturing plants. Richter hears the sound but doesn't understand its significance. That click represented more than just one connection. It meant the Wehrmacht had exactly 6 hours and 49 minutes before the first Sherman tank would roll across what they considered an impassable river barrier. But German intelligence was already behind the timeline, calculating based on assumptions that Bailey bridges made obsolete. While Richter reports construction activity to his company commander, American engineers are connecting the second Bailey section, then the third. Each connection takes exactly 90 seconds with an experienced crew. No delays for measurement, no adjustment time, no engineering calculations in the field. Every panel manufactured to identical specifications in British factories, where precision meant the difference between successful river crossings and catastrophic battlefield failures. Torres positions his fourth section as the first hint of dawn appears on the eastern horizon, revealing the scope of German defensive positions. Machine gun nests, artillery observation posts, sniper positions in buildings along the riverbank. The Germans have had months to prepare these positions, but they've prepared for conventional warfare, conventional timelines, conventional engineering. They haven't prepared for mass production applied to battlefield problems. "Keep it moving," Torres mutters to his crew, vapor streaming from his mouth in the cold air. "Germans wake up early." Private Rodriguez grins despite the danger. "So do Americans, Sarge. The banter helps control fear, but everyone knows the stakes. Successful crossing means Allied armor streaming into the German heartland. Failure means another month of war, maybe two, maybe more. The steel sections clicking into place aren't just bridge components. They're pieces of the puzzle that ends the war in Europe. But first, they have to stay alive long enough to assemble them. Coming up, the moment when German artillery found their range, and American engineers discovered whether mass production could survive mass destruction. The temperature drops to 30 °C as dawn approaches, ice crystals forming on steel framework that gleams in the growing light. German forward observers throughout the network report bridging attempt at Oppenheim sector, but request permission to wait for better visibility before calling artillery strikes. Standard procedure designed to conserve ammunition for confirmed targets. What they don't realize is that each passing minute means 3 more Bailey sections in position. The bridge is growing outward from both banks simultaneously, a concept that violates everything German engineers learned about bridging physics. Traditional bridges grow from one side to the other, requiring specialized equipment and extended construction time as engineers work across increasingly dangerous spans. But Bailey bridges eliminate that vulnerability through modular design that allows construction from both ends simultaneously. Standard sections enabling non-standard construction techniques that compress timelines and reduce exposure to enemy fire. Mass production meeting tactical innovation through systematic engineering. Morrison checks his watch. 0415 hours, 7 sections connected, 70 feet of bridge extending into the Rhine like a steel finger pointing toward German territory. Right on schedule, but schedules mean nothing if German artillery finds the range before completion. Morrison has seen what 88mm rounds do to construction sites. Twisted steel scattered across hundreds of meters, concrete reduced to rubble, broken bodies that were soldiers minutes earlier, but Bailey bridges were designed for battle damage through systematic redundancy, each section replaceable, no single point of failure. Morrison just has to trust British engineering and American manufacturing, but trust is a luxury that combat doesn't often provide. Across the water, German observers are starting to realize that American construction is proceeding faster than doctrine suggested possible. Range estimates being recalculated, artillery requests being upgraded from routine to priority. Timeline assumptions being questioned by officers who learned military engineering at schools where Bailey bridges were unknown, impossible, revolutionary concepts that hadn't yet been invented. Sergeant Torres positions his 8th section as the first mortar round whistles overhead, German 81mm tubes pre-registered on likely bridge sites during planning sessions conducted 3 weeks ago when Wehrmacht intelligence assumed they had time for methodical defensive preparation. The round splashes 30 meters short, close enough to send Rhine water cascading over work crews, but not close enough to stop assembly. Torres wipes Rhine water from his face, tastes the muddy current that's supposed to be an impregnable barrier, and reaches for the 9th section. 04 waiting hours, 8 sections in position, 80 feet of bridge spanning toward the German bank where Richter is about to get the shock of his military career. This is where traditional bridging would halt according to German doctrine and American experience. Assess damage, reorganize crews, call for medical support if anyone was wounded, evaluate whether construction could continue under enemy fire or whether the entire operation needed postponement until artillery could suppress German positions. Conventional military engineering assumed that enemy fire would disrupt construction, forcing delays while commanders regrouped and planned new approaches based on changing battlefield conditions. But Bailey bridges operated on revolutionary principles that neither German nor American doctrine fully understood. Modular design meant damaged sections could be replaced in minutes rather than hours. The bridge kept growing even under fire because individual components were expendable, replaceable, systematically redundant. German artillery observers reported direct hits but couldn't understand why construction continued at the same pace. Their doctrine assumed construction delays would accumulate with battle damage, creating opportunities for coordinated counterattacks. At 04:23 hours, German radio operators intercepted American communications that changed everything they thought they knew about enemy capabilities. Section 14 in position. Rate steady. ETA first span closure 0800 hours. The intercept reached Wehrmacht intelligence within 30 minutes, passed up the chain of command to officers who couldn't believe what they were reading. Analysts couldn't reconcile American timeline claims with known bridging doctrine, with everything they learned about military engineering, with basic physics of construction under fire. 8 hours to span 400 meters under enemy artillery? Impossible according to every manual, every precedent, every assumption about military capabilities. Someone had to be broadcasting false information to confuse German defensive preparations. The alternative, that Americans possessed rapid deployment bridging technology that made German doctrine obsolete, was too devastating to acknowledge. Better to assume deception than to confront the possibility that 5 years of defensive planning had been based on obsolete assumptions. But Morrison's crews knew the intercept was accurate because they were living proof that American industry had revolutionized military engineering. Section 15 connected at 0425, Section 16 at 0427. Rhythmic precision that represented months of factory production, systematic quality control, mass manufacturing applied to battlefield problems. Each panel carried identification numbers, quality control markings from British manufacturing plants, where precision meant survival for soldiers they would never meet, in battles they would never see, facing problems they could only solve through systematic excellence. Mass production enabling tactical flexibility through standardized components that worked everywhere, every time, under any conditions. The principles that made American factories dominate global manufacturing applied to the deadliest problems soldiers faced in combat. Industrial efficiency meeting military necessity through engineering that treated bridges like manufactured products rather than custom construction projects. German machine gun positions along the East Bank received orders to engage construction areas at first light, as soon as visibility improved enough for accurate targeting. MG-42 crews prepared ammunition belts and adjusted range cards for 400-meter shots across water that should have been an impregnable barrier. Easy targets once they could see clearly. Predictable work pattern. Static construction sites that artillery could destroy systematically once German gunners understood American capabilities and limitations. But they were calculating based on conventional construction timelines that assumed vulnerability, exposure, predictable patterns that made targets acquirable and destroyable. The American bridge would be 120 meters longer by the time German gunners could see clearly enough to aim effectively. Mass production had compressed construction timelines beyond German response capabilities, creating fait accompli situations where defensive reactions arrived too late to matter. Richter peers through his binoculars as dawn light reveals the American construction site, and what he sees contradicts everything he learned about military engineering during 5 years of war across Europe. Instead of massive timber frameworks requiring specialized equipment, he observes steel panels connecting like precision-manufactured building blocks. Fast, systematic, precise. Each connection identical to the previous one. No delays for engineering calculations that should require hours of surveying and measurement. No adjustments for local conditions that should complicate construction. Just systematic assembly of mass-produced components designed for exactly this situation. Mein Gott, Richter whispers into his radio, his voice carrying a mixture of admiration and terror. American bridge construction proceeding at unprecedented rate. This contradicts all doctrine. Request immediate artillery support. But the request will take 20 minutes to reach artillery command through communication networks designed for deliberate warfare rather than emergency response. Another 10 minutes to calculate firing solutions based on conventional targeting assumptions. 5 more minutes to load and aim guns positioned for different tactical scenarios. By then, American engineers will have added 15 more sections to their impossible bridge, advancing the timeline faster than German defensive systems can respond. Mass production meeting military necessity through systematic engineering that treats obstacles as manufacturing problems rather than